Hello guys, so welcome to yet another tutorial on encryption. So today's tutorial will be on the pretty good privacy. So PGP is another asymmetric algorithm. I will talk about that in a while, but the OpenPGP is the encryption standard based on the RFC 4880. So in the free version is the GPG, that's the GnuPG. In short, GPG. It implements the standard. So the GPG is a free software introduced in 1997, and it enables you to encrypt and sign your data and communications. So GPG is a complete and free implementation of the OpenPGP standard, right? So I'll be doing the demo in Linux environment. You can also use GPG on Windows using the GPG for Win, right? I'll show you where to get that. So PGP is a commercial product while the GPG is available for free. So PGP is not really an encryption algorithm in itself, but it relies upon other encryption algorithms. So like I've said, you can use PGP to encrypt files, encrypt your email, to digitally sign data, and to manage keys, right? So we have two types of encryption. We have the symmetric encryption and asymmetric encryption. The symmetric encryption is also widely known as the private key encryption, while asymmetric is known as the public key encryption. So in symmetric encryption, you just need one key, one key, a shared key that needs to be guarded and secured, right? So when you're encrypting something, you're changing the file or document or email into a plain text readable file. You're transforming it into a coded unreadable file or text, so that you're trying to maintain the confidentiality of that document. Only the person with the correct key will be able to read the file. So in asymmetric encryption, you're using key pairs, right? A public key and a private key. So both parties, like if you have two people that want to communicate that, Bob and Alice, for example, both of them have to generate a key pair, a public key and a private key. So they can exchange. If they want to do two-way communication, they have to both exchange a public key. So in asymmetric, you only have to focus on securing or protecting the private keys. The public key, you don't have to secure that anyway. So the public key will be used to encrypt the document. Once the document is now sent to the recipient has to decrypt the message or the file with the corresponding private key. So I will show you how asymmetric encryption works in using the PGP, right? The GPG. Now this is the documentation page for the GPG. I'll be dropping the link in the description as well for us. So you can easily, it has a lot of resources. You can go through it to, look at the capabilities, what it's used for, and other things. So, and if you're interested in using the GPG also for email self-defense or encryption, so there's also this resource. I'll also drop this link. It has good resources that I found here that could be used for securing your email communication, so that only the authorized person or the person you want to send it to will be able to, decode the message. So encryption basically is about encoding messages to an unreadable format, while decryption would be to decode it. And before you can decode any message, you need the correct keys. In asymmetric, you need two key pairs, right? So I will show you all that in a bit. So for this demonstration, I'll be using Ubuntu Linux. I'm going to be simulating two systems that want to share data. All right, so I have two systems here that want to communicate securely. I will assume the person who is on this system by the left is Bob, and the other person who is using the system here is Alice. So Bob and Alice want to communicate using asymmetric encryption, and in this case, I want to use the GPG encryption for that. So to do this, both of them in asymmetric encryption, both of them has to generate a key pair, right? So Bob will generate his own key, public and private key, Then Alice will also go ahead and generate her public and private key. So to generate the keys, but first I need to show you the version of GPG I'm currently using for this tutorial. So if I say GPG -- version, so you can see the version of GPG I have on this PC is a 2.4.4. All right. So, all right. So now to generate the keys, the version I'm currently working with is a 2.4.4. So to generate the key pair, so you use this command GPG. So the GPG is available. It should come with your Linux kernel or operating system. But if it doesn't, you can just install it. Sudo apt install GPG. You can install that, right? That's if you can. When you run GPG -- version and you can't see anything like that, so you need to install it. But I already have it on my 2 machine. So I'm going to say GPG -- full generate key. So I'm trying to generate public and private key. So I'm going to run this command GPG -- full -gen -keys. All right, so I'm going to hit on enter here. So you see I have, all right, so running the GPG full gen key now. So it's asking to select the algorithm to use for the encryption. So here you can see that the GPG is not an encryption algorithm in itself, but it makes use of other algorithms like the ECC, RSA, DSA, and LGAMAL, right? So, but for now, let's just select the RSA, the Ravel-Shamir-Adman algorithm, right? It's an asymmetric algorithm. So I'm going to just select option 1 to use that. Then it's asking what key size do I want to use. So the RSA uses a lot of key size, the bit, right? So I'm going to select a strong one, which is 4096. So I'll hit on enter here. Now it's asking me to specify how long I want the key that will be valid for. You can specify that in days, in weeks, in months, or years. So I want to use years, so I'll just say maybe for a year. So I'll say 1Y for it to be valid for 1 year. Then you see, you can see it's saying that the key expire 2025, right? So now, if you're okay with this, you just go ahead to hit on enter and okay it. Now I have to give the name, right? So let's say this is for Bob, right? And email address, I'll just use bob@bob.com. Then it's asking for comments. I can just have anything. I can just say, you can just add anything there, Bob's key or something. So now it's asking if, like, the next thing now, do you want to change? You can still go back and change them, or change the comment or email or okay. So I'll just hit on O that I'm okay with that. So now you need to create a passphrase to protect your key. So just for the sake of, just for educational purposes, right? Because I'm just using this in the tutorial, so I'm going to just give a simple key here. All right. So I will just say Bob 1 2 3 4. Right, so so make sure you use a strong key or a strong phrase, right, to protect your key. So I'll just okay it. So you're saying I'll enter an insecure passphrase, right? I just want to take it anyway. So this is just going to, generate. Let's wait for it to return. All right, so this is done now, and I have part of the key there. You see, it says using RSA 4096. It has created so day, and it's supposed to expire this day, and it's Bob's key, and this is the email. So we're going to do the same thing on the recipient. So I'm assuming the recipient is Alice. So I'll be doing that on this other Linux by the right. So I'm going to run the same command GPG -- full -key gen key. All right, so there we go. So we select the same algorithm, which is 1, the RSA, and we use the same key size, 4096 bits. And so again, we made it to be valid for 1 year. And is this correct? So we'll go ahead to say yes. So the name, so we'll call this Alice, and email address, I'm going to use Alice at alice.com. So I'm going to use alice at alice.com, then I can just say Alice's key. Alright, so I'm going to hit on okay, right? So also it needs a passkey also to secure that, a passphrase to secure the key. So I'm going to use just a simple one just for tutorial. So make sure you use a strong key, a strong passphrase to protect the key. Alright, so I'm waiting for it to return. Alright, so now we're all done, so I'm just going to clear both screen now. Generated public and private key, right? Both the sender and the recipient. Bob has generated his own public and private key. Alice has also generated her own public and private key. Now, the next thing I want to do, I want to store this key, both keys, both public, the public key, I want to store them somewhere. So I'm going to use this command, GPG, right? GPG dash ammo. So then I'm going to say dash export to export it for Bob, to export the key for Bob at bob.com. Right, so the ammo, we just make it to be in a readable format. So to export the key for Bob, then I want to store it somewhere. I'm going to call bob.pub because that's the public key for Bob. So I'll just use a simple syntax as this, and so I'm storing it in, if I store that in home, so you can see the key here, bob.pub, right? So it's a public key, so if you cut this, if you display this, right? So if you see Bob displaying this now, I have bob.pub. So you can see that's the key there, and you can see this is the beginning of the key where you have begin PGP public key block, and that is the end of the key there. So store that there. So I'll do the same on the recipient, on Alice's machine, to save the key to a file. So I'm going to also use the same command, GPG dash ammo, to be in a readable format. Then I'm going to dash export to export the key for Alice at alice.com. Right, so then I want to save it to a file I'm going to call alice.pub. So I also have the key there. So looking at the key here, if I do cat alice.pub, right, so this is Alice's key. Now, good. So we've generated the key pair on the two machine, and we've saved the public key as well in a file. Then the next thing now is to, well, I can show you the key, right? Let's list out the key. If I do it. Okay, now so we can list the keys, right? If you do dash list keys, you're gonna have the keys there, right? So you can see this is Bob's key that I just created, right? So you can as well list your, if you want to see the private keys as well, so you can use GPG dash list secret. You use this command here, list secret keys. So I'm not going to hit on entire because you have to, guard the private key. So, but this is the command you can use to list the key there, right here. So now that we've seen, I'll just make this a little bit bigger. So now that we've generated the two key pair on the two machines for both Bob and Alice, and we've saved the public key to a file. So the next thing is, so I'm going to send the public key for Bob. I'm going to send it to Alice, and I'm also going to send Alice's public key to Bob. The way asymmetric works is, if Bob want to send a message to Alice, Alice will have to send a public key to Bob. Bob will use Alice's key to encrypt the message, right? Then Bob will send Alice the encrypted message. So once the message gets to Alice, Alice will have to decrypt that message with a private key. So both the sender and recipient just have to guide their private key. So they don't have to secure the private key, right? So asymmetric encryption is a very secure algorithm, but it could be slow. So meaning symmetric is faster than asymmetric, but symmetric is not as secure as asymmetric. So let's go ahead to send. Now there are a couple of options to send this key, that they can exchange this key. They can exchange it physically, they can send it through a USB drive or another secure means. But for the sake of this tutorial, I will just be sharing the key on, I'll use GitHub. So for the sake of this tutorial, I have a GitHub page that I just want to use I will just upload it there. So if you check, I have so I'll just come here to just upload. Right, I've already created this GitHub repo, right, that I want to use. So it's a private repo. Don't worry, because it's a public key, you can choose to share the public key. You don't have to worry about securing the public key. So I'll just, I think I should have it here. All right, so here is Bob public key that I have here. So I'll just open it. And okay, so I'll just add that to that repo. So you can share the public key and maybe through USB or any other means. So I will do the same thing on this machine. I'm going to make the public key available for Bob on Alice's machine. So I'm going to upload the key here. Okay, I should have it here. Okay, this is Alice's public key. Right, so just open that here. All right, so just have to commit this message to upload it. So you can see both of them have the public key available now. So I have the two public key, right? So I have Alice's public key. So this Alice machine, Bob's machine is by the left, Alice's machine is to the right. So I'm just going ahead and download Bob's public key on Alice's machine. So I will just download here. Okay, completed. Okay, so I'll go ahead to download Alice's public key on Bob's machine. Yep, perfect. So I can go back to the terminal now. So I should have the two keys available there. Right, so it should be in download. So if okay, so on Bob's machine, so I can also, so I have to import, I have to import the Alice's public key into GPG, because if I don't do that, I won't be able to use that key. So I'll use this command --import. Then what I'm importing is in downloads, right? Downloads slash, so I'm going to have alice.pub. All right, so, okay, so imported. So I've successfully imported Alice's key. So I'll do that on Alice's machine to import Bob's public key. So to make it available for using the GPG. So running the command, use GPG --import, and I'll be same in downloads. So I want to install bob.pub. That's Bob's public key. So imported as well. Perfect. So now the next thing now is since I want to send a message to Bob want to send encrypted message to Alice. So Bob will have to encrypt it. So let's create a file here that I'm going to be using. I'll just say, so we want to create a file. So the touch, I want to say, just call it new secrets.txt. Let's assume there's a file. Okay. All right. So let's just have something in it. Just want to add some random text to it. I'll be editing it with Nano just to add some random text in it. So I just have to type this random text. This is a secret. That's just what I want in the file. Right, so I'm going to go ahead to save this. Right, so if I cut, all right, so that's the content. This is a secret. So let's go ahead to encrypt this file. Bob will encrypt it. So I'm going to encrypt that file with Alice's public key. So then Bob will now send the key or the message, the encrypted message, to Alice. So Alice will now have to decrypt the message with a private key. So let's go ahead to encrypt. So we're going to use this command, the GPG, GPG-encrypt. Then we have to specify the recipient, like as I showed you earlier, you can see I have other keys there. So you have to specify the recipient. In this case, it is Alice. Alice will be the recipient, alice.alice.com. So then the next thing now, I have to specify the file to encrypt. So I'm going to, so GPG-encrypt --recipient. The recipient will be alice.alice.com and newsecret.txt. So then it's trying to tell me if I can use all these. Yeah, so I'm okay with this. I'll just go ahead and type yes, and that's done. So I should have, if I list this, so I should have a file called newsecret.gpg. So doing that is going to create an encrypted file for you with a .gpg encryption. So if I view, let's view the output of the encrypted file. So new secrets, I guess. Right, so you can see all what we have here is a coded or encrypted content. The message we typed in earlier has been encrypted. So anyone who doesn't have correct key cannot view this file, and that's just the goal, one of the goals of encryption, confidentiality. Right, so now that Bob has encrypted this file, so Bob will have to go ahead and send this file, the encrypted file, to Alice. So I'm going to do that. Again, I'm going to use GitHub to send that. So I'll just come here to upload the file. Again, you can use any means to send this file, the encrypted file, right? You can. So, but I'm just choosing to use GitHub for that. So I show up the encrypted file. Here it is, the newsecrets.txt.gpg, right? So just have to load that in and commit the changes. Right, so I have the encrypted file here. So I'm going to retrieve it for Alice also from the repo. I'm going to retrieve it for Alice. Okay, so here it is here. So I'm just going to download it on Alice's machine. So download. All right, so done, so downloaded. So the file is now available for, let's view that, is available for Alice to decrypt. It should be in downloads, new secrets.gpg. Right, so that's the file there, all encrypted text. So Alice, So Alice will have to go ahead to decrypt the file now with a private key. So the file, the encrypted file received from Bob, Alice will have to go ahead to decrypt it with a private key. So now Alice is going to decrypt the key now, use the GPG command and specify the output. So you can specify, so let's call it secret_decrypted or decrypt. Decrypt txt, decrypt.txt. Then we have to specify the decrypt command there, then we have to specify the file to decrypt. In this case is in downloads. The file should be in downloads / new secret.txt.jpg. right? So using this now, just gonna hit on enter. As soon as I hit on enter, it's asking for the Alice's passphrase used to protect the key. So I'm going to pass in the passphrase here, and I'm going to hit on enter. So as soon as I hit on enter, so I have it there, right? So I have it there decrypted, right? So if I viewed it, I should have a file called secretdecrypt.txt. So let's view this. Let's view the content of the file now. So we'll just use a cat command, secretdecrypt.txt. So you can see that we have successfully decrypted the message. This is a secret. All right, so this is how you can use the PGP or GPG to encrypt your email. It could be email communication. You want to send email to someone securely, or you want to maintain the confidentiality of the message. You can encrypt it with GPG, or it could be a file or any kind of communications you want to use. So asymmetric encryption is highly secure, and GPG allows us to do that for free. So guys, thank you for following this tutorial to the end. Please don't forget to like and subscribe to my channel. Thank you.